Okay, so today we're going to have a look at problem solving using separable differential equations. So what we're going to do is we're going to consider solving problems where situations are modeled by differential equations. And often we're asked to search for information to discover any initial conditions. Okay, so we're going to have a bit of a practice at those two things. So let's just jump straight into an example. A salmon farm has an initial population of 80. The population grows according to the differential equation dp by dt equals 1/5 p, where t is the time in years. Part A, write an expression for p in terms of t, and part B, find the population after 10 years. So these are really common type questions, populations. So yeah, it's a good one to look at an example for. So the first thing we want to do is write an expression for p in terms of t. What I'm going to do is I'm going to write out my dp by dt equals 1/5 p. All right, now with separable differential equations, we know we can write this in the form of dp by dt and bring a dt to that side and do the same to the other side. So without changing anything, we have brought that. The reason we do that is because we want to get rid of this dt at the bottom, and what we're left with is dp equals 1/5 p dt, and we can divide both sides by p. So we've got all of our p's on one side and all of our t's on the other side. So we end up with 1 on p dp equals 1/5 dt. Now, we've had some practice with separating differential equations, and what we can do from here is just integrate this one with respect to dp and dt. So if I move up here, the left-hand side is going to become the natural log of p, and the right-hand side is going to become 1/5 t. So that isn't the end of it, not even of that integration, because we know we have to always add our plus c constant. Now, because we want to get it in terms of p, we want to add our plus c to the opposite side. Okay, that might become a bit clearer later. All right, so we've got our natural log of p. If we want to get p by itself, we can take e of both sides equals e 1/5 t plus c. All right, we know that these are the opposite functions, so we're going to be left with just p equals e to the, I'm going to start writing t on 5 instead of 1/5 t on 5 plus c. And we can do one more simplification to get p equals, because we can write this as e to the c, e to the t on 5 using our power rules. And e to the power of c is just like a constant to the power of a constant, so we can write this as like a e to the t on 5. All right, so now we have an expression into the terms of p. So one of the things we started off looking at is you often must search the information to discover any initial conditions. So if we write it like this, we don't actually know what a is, but we do know at the initial population, initial meaning 0, is 80. So if we just come back to this left-hand side, I know that p, the initial condition, so p of 0 equals a e to the 0 over 5. And so if I put in 0, that's going to equal 80. All right, anything to the power of 0 is 1, so I'm left with a equals 80, and therefore my p is equal to 80 e to the t on 5. And I have done my first component. I've worked it out. All right, so part B, we have to find the population after 10 years. Now we have a function that shows us the population at any time. So we can just substitute in 10. So P of 10, so the population after 10 years is equal to 80 e to the power of 10 on 5, which is the same as 80 e to the power of 2. And if you put this into your calculator, you get this equals approximately 591. So you want to write a little sentence like the population after 10 years is 591 salmon, to show you've understood the question. All right, so that's problem solving. We'll have a go at a few of those now. Thank you.